Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So we are gonna continue our lab. In this video, we are gonna discussing about switching, different from the video before, previously video that I have discussing about routing, and now we are gonna move to the another chapter that is switching. So there is about approximately 13 labs in here. I just wanna switch CCNP labs. Then we just need some not routers but switch. I'll switch. Yes, here I want this 256. I need just one, and then for VPC. Turn it on, and then VPC. Here we need 4. Yes, 15A1. Udah. So the lab 1, we just implementing basic VLAN or standard, and then in PC1 and PC3 it's in the VLAN 2, and PC2 and PC4 it's in the VLAN 3. So 1 and 3 in 10 VLAN 10, and also VLAN PC2 and 4 in the VLAN 3. With okay, routing interface range, because I don't wanna do it one by one. Shutdown IP address no shutdown. Shutdown, and then switch mode access, switch access VLAN 2, and then interface range .1 and 3. Okay, switchboard mode access, switchboard access VLAN 3. Do show VLAN brief. You can see in here, and then we configure the IP address in the VPC. I set the PC1 10.1.1.1. Okay. Udah. IP 10.10.10. Wait. Why are so lagging? IP 10.1.1.1/24, and then in VPC3 IP 10.1.1.2/24. Lah. And then in VPC2 and in VPC4, mm, 20. Allah Akbar. Mm. And then we ping each other. Okay, it's come success. Now swapping to the 20.1.1.2. Okay, so we have completely this lab one. So we're gonna going into the lab two, implementing what? Configuring trunking. We're gonna configure trunking in this lab. Set up the lab first. we have switch 1 and switch 2. So we're gonna need to switch, and then connect with the two PC, VPC. So we are gonna need 4 VPC. Here PC1, PC2, PC3, and PC4. Then start our VPC. We're gonna setting the switch. We wait for the reboot here, but we're gonna make this the in this VLAN 10, and in below is VLAN 20. Okay, now in switch 1, conf the interface to the gig and make it transparent. I hope you can see it. Interface gig switch mode trunk. You can see that the encapsulation is auto. If we see do show interface trunk, no to show interface. Or we can see to show IP protocol. By default, Cisco will using the protocol. The name is ISL. We have to turn that into the .1 queue, so the switch will give the Ethernet frame some tagging into the packets. Switch trunk encapsulation .1 queue, and then switch mode trunk. In here too, and conf pos SW2 interface will be 0/0 switch port trunk encapsulation .1 queue switch port mode trunk, and then we have to make interface gigabit 0/1 get into the VLAN switch port mode access switch port access VLAN done. then interface gigabit 0/2 switch port mode access switch port access VLAN 3. Also in here interface gigabit, okay, no, gigabit interface gigabit 0/1 switch port mode access switch port access VLAN 3. Interface gigabit 0/2 switch port mode access switch port access VLAN 20. And then after that we have to try ping from one to another, and also we see the task because I configure the space. Configure ESL trunk between SV1. Okay, we are going to set the encapsulation ASL first actually. Interface gigabit 0/0 switch port down encapsulation ISL, and then in here interface gigabit 0/0 switch port mode switch port down encapsulation that one ISL. To show interface trunk we use encapsulation ISL. So we're gonna do give some IP in IPv4, PC4 and PC6, IP20, and then in here IP20.1.1.2. In PCT IP10.1.1. In here IP10.1.1.2. If we ping to another, not reachable in same hidden. Okay, why it's not reachable? PC5. Interface gigabit 0/0. Do show run as interface. Access VLAN 10. Okay, same. Oh yes. I see. Because I wrong. Do show run as interface. Interface gigabit 0/2 switch port access VLAN 10, and in one switch port access VLAN 20. And then we try again, still same. IP, show IP. see again why it's done wrong. S interface, switch port access to Intel, B0/1, switch port mode trunk, ISL mode trunk. If we try to ping from here, 20.1.1.2 is the same, not reachable. Ping 20.1.1.1 still same. But in this documentation, if we see the trunk, it's, I don't know why it's successful. If I set the IP, it's I can VLAN 10 IP address 10.1.3 5.0, and then I want to do ping 10.1.1. Okay, I can ping it too. Oh, maybe show interface VLAN 10. I shut down and we ping it. It's the same. I can ping it. Do ping. Okay, in the point is, if I setting the ISL trunking, it done successful. But if I change it into the switch port constellation.1q, and then in here too, interface KB0/0 switch port. What is this? Switch port encapsulation.1q. Then we ping again. It's not reachable. Why does it happen? Interface gigabit 0/1 which would other access which would access and then we set again and do show window. Okay, we check again in here, do show VLAN brief. Okay, we ping again. Now after that we check in here too, ping. Okay, here. Okay, also in here to the one. Okay. Mm. Because before I change again the protocol of encapsulation, the interface gigabit process zeros encapsulation ISL, and then in here too interface gigabit zeros ISL. Repeating it. Okay, timeout. You can see here timeout. Okay, not timeout. Oh yes, timeout. If I try in the here, timeout. But if I setting dot one queue and then in here dot one, what dot one queue, we see packet from the PC5 is still timeout or no, still timeout. Now you can see that it's not. The point is, if we use the ISL protocol, it can bring the VLANs because there is no VLAN tagging in there, so we have to use protocol one queue because there is in the packets of the Ethernet frame, it will tagging some carrying some VLAN ID. We go to the lab 3. Yes, lab 2, we're going to the lab 3, implementing inter-VLAN routing. So just from like the topology before, but we are gonna uh, add some one router. Oh no, just one switch and one router. We see the task, creating VLAN and assign port FA1. That's it, pick VLAN. The sub interface on to complete this task. Task 2, implementing inter-VLAN communication on a multi-layer switch. Okay. we are gonna set up one router in here, and then one switch, and then four VPC. Wait, I want to pause this video. We'll continue again about interference. Now we have to configure the switch first. And const interface, give it 0/1 interface, switch port mode access, switch port access VLAN 10. Actually I want to go with range R1 and also 0/no. Switch port mode access, switch port access VLAN 10. Then range base 0/2, 0/3, switch port mode access, switch port access VLAN 20. And then we set into the 0/0 switch port trunk encapsulation .1Q switch port mode trunk. After that we setting the IP HPVC 10.1, and then in here 20.20.20.1, then in VPC5 10.10.10.2, and in VPC6 oh, if we ping 10.10.10.2 we have been complete. But if we ping to different VLAN from the VPC, we can't, because we need some gateway to bridge or connect them between the VLAN. So we will make them in the router as a gateway. Interface 0/0 no shutdown, and then we make some sub interfaces. 10 encapsulation.1Q 10, and then we give them IP address for the gateway and also to VLAN 20 to show IP interface brief. Now we have them, and then we're setting the gateway in here. Gateway, this is, we set the gateway in here too. 2020 eh, in fields, yes. And after that we do ping again. You can see I can ping into the another VLAN. If I ping into them, and then in VPC4, if I ping the I'm sorry, then we do ping for 10.10.10.1. You can see that success and then success. Okay, that is for which lab in here? This is for lab 3. We are going to the next lab. What is the next lab? No. If we using, now we are using what's we are using the routers, but what if I want to using the I want to use switch, multi-layer switch. Okay, I can't. Here is the multi-layer switch actually, but I want to add in one again. This is the multi-layer switch based on, okay, this is, we don't have to this. If we ping again, not reachable, but if we give some interface VLAN 10 for IP address 10.10.10.254, and then the VLAN 20 for IP address also you shut down, you show IP interface brief. Okay, and then we check again duping. You can see it's timeout because wait, show IP. Okay, IP routing. You can see in here from VPC 3 I pinged into, okay, successful, and also I pinged to 20. And then 1. Okay, this is for MLS. We can easily communicate with multi-layer switching. without router. Propagating VLAN configuration with VTP. So we will configure VTP server, configure switch 1 as the VTP server and the other switch as VTP client. Use netmetrics as the domain name and authenticate the relationship using Cisco 123 as the password. And then we wipe them all. We wait for booting up. Um, and then I want to explain a little about VDP. So VDP is just if you know about VLAN, if we configure VLAN in switch, is just for local significant. And then if we want to pass the VLAN traffic, we have to know that the name of the VLAN also the VLAN number. And then if we configure one by one per router, it's so wasting time. So with VTP, VLAN trunking protocol, that one of the server, one have role as a server, he will give the advertisement of the VLAN configuration to the another VTP client. So it will be synchronization by revision number instead of the VTP, instead of synchronization with the server, but it will be synchronization with the highest VLAN or the latest highest revision number or the latest revision number. So maybe n conf t, and then we make the interface gigabit 0/0 switch port trunk encapsulation dot one q switch port mode trunk. And then also in here and conf t interface gigabit 0/0 switchboard mode switchboard mode encapsulation dot one q switchboard mode trunk. Why we set the trunk? Because we want to pass the traffic, pass the VLAN advertisement. And also if we don't use trunk, for what we use the VTP, and also configuring the VTP, I mean, because the aim or purpose of the VTP is to make the VTP client with synchronization with the VTP server. Okay, if we make this the server, VTP mode server, and also VTP domain, what he asked, netmetrics, and then VTP password Cisco123, VTP password Cisco123, and then if we here VTP mode client, and then VTP domain netmetrics, VTP password Cisco123, and after that you can see the fill and brief in here, just the default fill and in there. To show fill and brief, just default in there too. If we make fill and 100 until 200, name bintang, okay, and then I will make 300 14 until 500. To show fill and brief, you can see that many of them in here. If we see to show fill and brief in the here, you can also see the many of the fill and their synchronization with this VTP server. Okay, implementing spanning tree. Okay, spanning tree. Configure switch 1 as the VTP server and the other switch VTP client. Configure as we want to be the HTTP route for VLAN 1. Change the forward delay time such that the port transition from listening to learning in just 6 seconds instead of the default of 15 seconds. Configure FA trunk as .1Q trunk on both the switch. We have been made the VTP, and we just want to now we want to make the one link again, and then change the forward delay such that configure switch 1 to be the STP route for VLAN 1. We want to make the switch 1 to be spanning tree, exit first, spanning tree VLAN 1, priority route. I want to make them as root, switch 1 root primary, and then also configure learning state in just 6 seconds. Spanning tree VLAN 1 forward time 6. Okay, if you want to see spanning tree, do show spanning tree in here. You can see that the bridge priority is in here. This bridge is the root. If we see in here, do show spanning tree, the root is, this is not the root, but this is have the root port because that facing the root bridge. You can see the forward delay is 6 seconds for root in here, forward delay 6 seconds, and then this bridge is the root. We see again what is the task 2, configure FA0/1 and SV1 to operate in port fast mode. So what is the use of the port fast mode? It's used for in SDP we have blocking, learning, listening, and forwarding. You can see SDP states we have 5 of them. First, it will be blocking, and then second, it will be listening, and then learning and forwarding. For disable, I don't know what is it. And then if we use pass of port fast, from the blocking states, we just going through into the forwarding. This is for client because it is not really need about the BPDO bridge BPDO packets. So BPDO bridge protocol data units, and then we set the VPC in here 100 megabit up to, I'm sorry, I just make it one VPC, and then there is 4. Now turn on the VPC, and then we configure the interface range gigabit 0/0 until 4 until 3, switch port fast, no, port fast spanning tree, port fast, switch port mode access, switch port spanning tree, port fast mode. If we see do show spanning tree, show spanning tree interface gigabit 0/0 0/1 0/2 0/0 detail. You can see that BPDO the port is in the port fast edge mode. Now we're going to the lab set task 3. Configure switch 1 to quickly switch its root port in the event of an uplink scenario based on the task 1. So the configure as we want to quickly switch its root port in the event of an uplink failure. Trunking should be configured between the switch. Okay, we connect them into the one switch again. Mhm. And then turn on this switch, and also in here conf t interface gigabit gigabit 0 1/0, and then switch port run encapsulation dot one q switch port model run interface gigabit 1/1 run encapsulation dot one q switch port model run. And then in the switch 2 and conf t interface gigabit 0/0 switch mode encapsulation dot one q switch port mode trunk, and also for one. Okay, and then we make the spanning tree VLAN 1 as the root primary priority spanning tree VLAN 1 uh, wait spanning tree okay, we go exit first. Spanning tree VLAN 1 prior root primary, and then we set the spanning tree uplink phase. Spanning tree uplink phase to show spanning tree interface. Show spanning tree. Now this is the root bridge. So if we shut down the interface of 1/0 shutdown, it will be switch the port to show spanning tree. To show spanning tree. You can see we see in the switch here to show spanning tree. This is the blocking part, but if we shut down the interface through the 0/0, what happening interface 0/0 shutdown to show spanning tree, you can see that the you can see in here 0/1 in the port blocking before, but after I shut down the interface 0/1 is in the forwarding state, a listening state. And then if I do show spanning tree, it will be in the forwarding phases, and then also it will be the root port. Okay, and then the task for configure port first on port FA0 slash 9 between S. Default outputs are in dynamic disable. The auto negated purpose should not be enabled on trunk. There is a possibility of loops. Configure the port fast. By default, output are in the dynamic desirable mode. They auto negotiate to become trunk. Port files should not be enabled on trunk as there is a possibility of loops. We need to shut down the port enable password and both enable BPDU word on port FA to stop BPDU on that port. So if we I still not, maybe I want to. Okay guys, I'm gonna continue again about the this switching lab. We have been on the task 4. Before we have been do the uplink fast, spanning tree uplink fast, and now we are gonna configure podcast on FA0 slash 9 between switch 1 and switch 2. By default, all the ports on the switch are in dynamic disable. They auto negotiate to become trunk. Purpose should not be enabled on trunk as there is a possibility of loops. We need to shut down the port FA and enable purpose on both the switch on port FA0 slash 9. Enable BPDU guard on port FA0 slash 9. Switch 1 stop BPDU to stop BPDU on that port. Okay, we have to try it. We get rid of this link, and then in here we're going into here too, and then interface and conf the interface 1.1 1/1, and then shut down, and then what they port pass spanning tree port pass port pass, and then enable BPDU port. Switch port spanning tree BPDU. Okay, spanning tree BPDU port. BPDU port enable, and then in this switch and conf the interface, and then shut down spanning tree port pass. Now shut down, and then now shut down in here. what is happening. If we see the show ID interface brief, interface gigabits 1/1, no shutdown, and then in here interface gigabit 0/0, no shutdown. In to show interface gigabit 0/0, you can see if we enable the PDU guard and then we receive the PDU, uh, our interface will be into the line protocol is down. You can see that in air disable. Now into the task 5, configure R1 to send the PDU to switch 1, enable PDU guard on FA 0/3 on SY1 to block access port FA 0/3 in switch 1 if any VPDO received. Okay, I don't know how to make this into the gift BPDO, but I just follow this interface, bridge group 1, and then choose protocol IEEE, and then bridge 1 priority 4096. Let's add router, and then but in here we turn this into receiving the PPDO. Okay, and then we give this 0/1/0, and then spanning tree PPDO guard enable. If we see in here again, visual interface is still erasable, so we have to shut down and no shut down. Then do show interface devices. Okay, connected, protocol is up, and then we give this wait still booting. Wait. Okay, we continue. Interface will be 0, bridge group assigned to 1, and then priority bridge 1. Okay, bridge 1 priority protocol and then we see in the here to show interface 1 gigabit 1/0. To show interface to show interface gigabit 1/0 to show run as interface. Okay, BPDU board enable, but I don't disable in this interface. Bridge group 1 bridge 1 priority bridge 1 protocol or interface no shutdown. Wait, now we can see after I no shutdown this interface, we see again here. Now there is input into air disable. So the video board if we activating the BPDU guard in the interface, so if the interface receive the BPDU, it will be put the interface into error disable, and if we want to recover them or put them back into the normal interface, we have to shut down and don't shut down. Then continue again. Task 7. Configure as we want to be root for VLAN. Configure root guard feature on switch 1 port FA9. Okay. Maybe I make the new one. we get into the field and then we set the BPDO root to show run as interface gigabit 1 to show run. Okay, get rid of this in here and then in here you show run as one slash. Okay, and then in here too and confi into to show run as interface. Okay, now we have been complete again and we have to turn this into this interface range gigabit 1 plus 1 until 2. Okay, and then spanning tree VLAN 1 root primary VLAN 1 root primary. Okay, and then after that we see in here uh, spanning tree PPDU spanning tree PPDU guard root. Okay, guard spanning tree guard root. Okay, root guard enable on port gigabit interface. And as we can see, if we do show spanning tree, we can see that in the VLAN one, this is bridge is the root and the priority is here. If we set the primary in here as the priority of the VLAN, let me see that interface range gigabit gigabit 0 gigabit 0/1 until 0 until 1, and then spanning tree with VLAN 1, and then priority we set it down into the priority. Okay, span tree root guard block, root guard blocking for gigabit on. Okay, let me see again to show span tree. This bridge is still root in, I don't know what it's meant. Okay, we see in here to show spanning tree. It will be like this. Spanning tree workload is enabled. If we change the VLAN, so spanning tree detail is broken, root inconsistent. Port is blocking for respondent. As root word is enabled on switch one, the port on switch one change to root inconsistent port, thus blocking the port when spare BPDU are received on switch one. Port blocking port. So you can see that in blocking port. If we see the detail to show interface gigabit 1/1. Okay. Detail. If we see the detail do show spanning tree. Okay, do show spanning tree. Span interface gigabit detail. Root inconsistent. You can see that the root inconsistent. And we see for 1/2 it's the same output, root inconsistent. Now we have go to the task A. It's not too important. We just that for like 1 until 5. See you in the next video.